Hello, my name is Muhammad Syazwan bin Mustaqim from 4D2 and this is my video of ECG263 mini project. In this mini project, there will be 5 experiments that will be conducted. First, for water content determination, the objective of this experiment is to determine the moisture content of the soil. For particle density, the objective of the experiment is to determine the particle density and specific gravity of the soil. For dry sieving, the objective is to determine the percentage of different grain size contained within a soil. For permeability, the objective is to determine the coefficient of permeability of fine-grained soils. And lastly, for field density, the objective of the experiment is to determine whether the desired compaction level in an area has been achieved. This is my sampling location of my soil sample, which is a field area in front of my house. For water content determination, the apparatus that we needed is tray, soil sample, weighing balance and shovel. Record the mass of each tray and label it. After extracting our soil from the sampling location, divide each sample to the tray with each sample weighing about 1.5 to 2 kilograms. Spread the soil evenly in the metal tray and expose the soil to solar radiation and wind for a air drying process for overnight. After overnight, record the mass of each tray plus dry soil and calculate the water content. For particle density, the apparatus that we needed is glass jar, water, soil sample and weighing balance. First, label each of the glass jar. Next, record the mass of each glass bottle and its cap. This is our M1. After that, fill in the glass jar with dry soil for about 1/3 of its volume. Then, record the mass of the dry soil, glass jar and its cap. This is our M2. Then, pour some water until each of the soil is fully soaked. Then, leave the soil for about 30 minutes. After 30 minutes, pour some more water to fill it up completely and close the glass jar. Then, record the mass of the glass jar, its cap, soil and water. This is our M3. Next, clean the glass jar completely from any soil and wipe it up with tissue. After cleaning it up, fill the glass jar entirely with water. Then, record the mass of the glass jar, its cap and water. This is our M4. Finally, we can obtain the particle density and the specific gravity of our soil sample. For dry sieving, the apparatus that we needed is tray, weighing balance, DIY sieve set for about 4 different size and soil sample. First, weigh each of the sieve set. After that, prepare the soil sample for about 1.6 kg. Then assemble the sieve set according to ascending order with a tray at the bottom. Carefully pour the sample from the top and shake each of the sieve set. Next, record the weight of each sieve with its return soil and the soil at the bottom tray. Now, we can determine the particle size distribution of our soil sample. For permeability, the apparatus that we needed is plastic bottle, bucket, ruler, marker, soil sample and water. First, drill some holes at the bottom and cut the top of the plastic bottle. First, mark each of the bottle and record its height and the diameter. Mark 4 level points at the top of the bottle with constant height. Next, fill the bottle with the soil sample until desired height. After that, fully compact the soil sample that is inside the bottle. Leave it for a while until all the soil is fully saturated. After it is fully saturated, add some more water until it reaches the H1 mark. Then we can start observing the time for the water to reach from H1 to H2, H2 to H3 and H3 to H4. Then record the time taken for the water to reach each level. Repeat the experiment for the other two bottles, and finally we can calculate the coefficient of probability of our soil sample. For field density, the apparatus that we needed is shovel, steel can, weighing balance, mallet and small container. First, record the mass of the steel can. Next, immerse the can into the field by using mallet, but be careful for not knocking it too hard or the can will dent. After the can was fully submerged, carefully extract the can from the field area. Now, record the mass of the can and the soil. Repeat the experiment for another 2 times to obtain the average field density. From each of the sets, extract some soil sample to obtain the moisture content. Now, we can calculate our dry density of our soil. After this mini project, there are several things that I learned. First, I learned how to conduct my own experiment by using DIY apparatus. Next, I also learned how to separate the such particle in our soils. Furthermore, I'm having the experience of conducting my own experiment to know the behavior of the soils. Lastly, this mini project teach me how to become innovative and creative in solving problems in our daily life. Discussion. There are many errors that comes up while doing this mini project. This may be caused by the lack of apparatus, as all the apparatus that I use in this mini project is based on what I have on my surrounding. So the conclusion is, the objective of this experiment was successfully achieved. We can obtain the behavior of soil at our sample area with a proper technique. To avoid any errors in our result, the apparatus that we use must be capable to match the apparatus used in the laboratory for a real experiment. That's all from me. Hope you enjoyed this video. Thank you.